RL circuit. Okay, so now consider to take an inductive circuit. Okay, why we are not using inductors while we are analyzing any DC circuit? What is the reason why you are not using inductors? Okay, so we can answer the question. Answer the question why we are not using an inductor while analyzing a DC circuit. Okay, after I will complete, you can able to analyze why we are not using. Okay. So now coming to this inductor which is connected in series with a resistor. Suppose I will ask you, listen to all of you. All of you listen because this is important. If your theory is important because you will be getting the derivation. This is very, very important. Okay. And as well as related to this, you will get problem. Theory as well as problem, both are important. Okay. So you should understand what is the concept, which formula you have to apply. Okay. So now tell me, at the instant when I will close this switch, I have connected with the help of the switch. The instant I will connect a switch, then tell me what will be the circuit current, what will be the condition of the circuit. Tell me. Hmm.
Ma'am,
Yes,
at the
tell.
instant, current will not flow.
Current will not flow. Why current will not flow? I have closed the switch. Why the current will not flow?
Ma'am, cause of inductor.
Hmm? Problem with inductor.
Inductor.
Why? Inductor does what?
मैम
Inductor
रिवर्स
does
ईएमएफ
what?
पड़ेगा.
Inductor is all opposes the cause. मतलब मैम जब बढ़ेगा तो इंडक्टर कम करना चाहेगा और जब कम होगा तो बढ़ाना चाहेगा.
मैम रिवर्स ईएमएफ पड़ेगा.
हाँ क्या होगा?
रिवर्स ईएमएफ.
Reverse
रिवर्स वोल्टेज.
EMF. Reverse voltage.
हाँ ऐसा कुछ पड़ेगा.
All of you agree that no current will flow in the circuit once I have closed the switch. Once I have closed the switch, no current will flow in the circuit. All of you agree. So I will come to the first point. I will come to the first point when the instant when t is equal to 0, S is closed. T is equal to 0, S is closed. Okay. So what will happen to the condition? Tell me. Yes, all of you agree. Somebody has told that there will be no current in the circuit. All of you agree that there will be no current in the circuit. Tell yes or no. Answer quickly. We are wasting time. Yes, tell. All of you agree that there will be no current in the circuit. Tell. I need more answers from you. More answer from all of you. Let it be wrong, it's right. If you are telling wrong, then justify. If you, whatever the answer you are telling, you will justify. Yes, tell.
Ma'am, current will flow, I think, because the inductor opposes the change in the flow of current. But here,
Supratim, tell me.
there is no.
Okay. Current will flow. Supratim, tell 839, roll number. 839 absent.
Ma'am, yes, ma'am, current will not flow.
Are you listening to me?
Yes, ma'am, yes.
Okay. Current will not flow. Vivesh, will current flow or not flow? Vivesh? Vivesh is not there in the class. 848.
AC
Abhijit,
current will
854. Who is
Yes, ma'am.
answering? Vivesh.
no, ma'am. 817. Ma'am, AC will stop because inductor stops the flow of AC current. So
Still, I am not clear what exactly you are telling. Now, current will not flow. Listen, current will not flow in the circuit. Why? Because inductor, nobody is telling that thing. Current will not flow in the circuit because this inductor is having a property. What is that property? Inductor is having a property. That property, that property is called as what?
Inductance.
Property we are having, that the property is called as what? Inductance. Just wait one minute. I'm having problem. Yes, inductor is having property. That property is known as what? Inductance. What is this inductance? Inductance has a property that it will oppose any sudden change in the current. Okay, it will oppose any sudden change in the current. Now, the instant when the switch was not closed, what was the current in the circuit? Listen, all of you carefully. The instant when the switch was not closed, what was the current in the circuit? Current was equal to how much?
Zero.
Zero.
So,
Current was equal to zero. Now the instant at t equal to zero, when I'm closing the switch, because due to the property of the inductor, what will be the current in the circuit? Because due to inductance, what will be the current in the circuit? I will be equal to 0 at t equal to 0. Am I clear, all of you? If there is any doubt, all of you listen carefully. If there is any doubt, you can ask a number of times. Understood, all of you?
Yes, ma'am.
Okay, because due to the property of inductance, the current will be equal to how much? Current will be equal to 0. Just before closing of the switch, the current was 0. So, just after closing of the switch, the current will be equal to 0. Now, coming to when I close the switch, what will be the equation in the circuit? What will be the current equation? Tell me. Tell. Sorry, Kirchhoff's voltage law equation. Tell me. What will be the Kirchhoff's voltage law equation? So this is t equal to 0. Now I will, okay. So you tell me when t at infinite, what will be the condition of the circuit? Long time the switch has been closed. Okay,
current will
a
flow.
long time the switch has, what will be the current? Current will be equal to how much? Current will be equal to how much? Obviously, the current will be rising. Yes or no? Current
Yes,
will
ma'am.
be rising from t I equal to 0 when I have closed the switch. The instant I am closing the switch, the current is equal to 0. But gradually, you have when you have connected the switch, then obviously the current will increase, right? The current will increase, and at t equal to infinite, the current will become maximum. Understood, all of you? The current will become maximum. So what is that maximum current? That will be equal to how much? That will be equal to how much? Tell me.
V by
That
R.
will be equal to V by R. Okay. That is your maximum current will flow at t equal to infinite. Now in between I will ask from 1 to 2, t to 0 to t at infinite. That is your that your condition number 2. Okay, at any instant after closing of the switch, nor it is t equal to 0, nor it is t at infinite. At any instant of closing of the switch, at any instant of closing of switch, that means what is the value of t at that time? What is the value of t? Tell me. T is equal, t is how much? T
And between
is
0 to
greater
infinity.
than, T is greater than what?
Greater than 0.
Greater than
T
0 and
is
less
greater
than
than
infinite.
0, less than
Less than
infinite.
infinite.
Okay, this is the condition. So now tell me what will be the correct current? What will happen? Now here current is increasing from 0 to infinite. Now I have closed the switch. I have closed the switch. So what I have done, I have closed the switch. Current is increasing from I to 0 to how much? I equal to maximum. So in between I is increasing. This implies that I is increasing. Okay. Now I have closed the switch. What is the voltage equation? Tell me. I write down VR plus VL will be equal to capital V. Am I correct or not? Okay, because I have closed the switch. All of you understood or not? VR plus VL is equal to V because I have closed
Yes,
the
ma'am.
switch. All of you got it? I have
Yes,
closed
ma'am.
the switch, so my Kirchhoff's voltage law will be applicable. So what is my equation? The equation is your IR. Sorry. So the equation is your IR will be equal to how much? Sorry, IR plus what is the value of VL? VL you know, VL is equal to how much? L di by dt. This equation you know it or not? Voltage across the inductor will be equal to how much? L di by dt. This you know it or not?
Yes, ma'am. 12th में पढ़े थे.
Yes, ma'am.
L di by dt, that is equal to V. Okay. So now here V is equal to IR plus L di by dt. That means as current is increasing, listen, because my current is increasing from I equal to 0 to I equal to maximum. So as current is increasing, understand all of you very carefully. Okay. As current is increasing, obviously what happens to this one? What happens to this one? This is increasing because R is my
Yes,
constant.
ma'am.
Okay. So this is IR is increasing. What happens to your, as current increases, VR, I can write down VR that is equal to IR increases. Am I clear or not up to this? Clear? All of you? All of you clear?
Yes, ma'am.
Okay. So what about VL? Because my V is, what happened? Tell. What happened?
Nothing.
Okay, okay. So now you know that this is constant, voltage is constant, right? So if this is increasing, this factor is increasing, what happens to this one? In order to maintain this
Decrease.
constant, what will happen? This will decrease. So VL decreases. That means L di by dt is decreasing. Okay. Now L di by dt is decreasing, means which is decreasing? Tell me. L di by dt is decreasing, means which is decreasing? L is constant? L is constant? Yes or no? Inductance value is constant. As L is constant, so which one is decreasing?
DI
Di
by
by
dt.
dt is decreasing. Very good. Is decreasing. Okay. So that means it is decreasing, and after some time it will become, after some period it will decrease and it becomes what?
Constant.
Ah, it will be constant
Constant.
or it will be zero? It is decreasing.
Ma'am, decreasing it will be zero.
Yes,
Zero.
it
Yeah.
will be zero. Understood all of you?
मैम ये
So,
तब ना जब स्विच लगा हुआ है तब करना.
हाँ, स्विच लगा हुआ है, but it is not at equal to zero, not at infinite. In between 0 to infinite, what is happening? Switch लगा हुआ है. Otherwise, how this equation will be valid? Unless you have closed the switch, how this equation will be valid? This equation is valid only when you have closed the switch, right? Got it?
वो करंट
So,
जीरो.
करंट जीरो होगा? करंट कहाँ जीरो हो रहा है?
ओ सॉरी
Current
रेट ऑफ फ्लो
di by dt.
जीरो हो रहा है. Yes, ma'am.
Okay, some period it will become zero. Which one will become zero? Which one will become zero? Di by dt will become. Okay. So di by dt is zero implies that what? I will be what? This implies
Constant.
which
I
is
zero.
constant. Implies I is constant. Okay, so that constant value is how much? It is decreasing. That means here what happens? Initially di by dt is decreasing, and at this point di by dt is equal to how much? Zero. Why? Because this is your constant value, right? What or not? This is your constant value. I at maximum, that means I is constant, that is your I maximum. That is equal to how much? V divided by R. Am I clear what is happening? Got it or not? All of you got it?
Yes, ma'am.
All of you got it, or again I will tell you? All of you understood?
Yes, ma'am.
Girls are not.
Yes, ma'am.
Okay. So simple thing, simple equation. I have told you that initially at t equal to 0, the current is 0. At t infinite, current is maximum. Okay. What about to VL? What about the value of VL? Yes, here I will obviously write down in the further condition 2 and 3. What is the value of VL here? Tell me. Tell. Yes, tell. So I have
L,
explained
L.
everything.
L.
And
I
So
equal
VL
to
will be
0. VL will be equal to L. How it is L? How you are equating a voltage with a inductance? What will be the value of VL? Ah, I do not know why so much time you are taking.
ma'am, it will be zero. Ma'am,
Zero.
because it is equal to zero, na?
Ma'am, zero.
Ma'am, zero.
Why it will be 0? Why it
Ma'am,
will be
because
0?
I is equal to zero.
Ma'am, DI.
मैक्सिमम होगा इस टाइम.
Huh? Why it will be 0? Tell me.
In line.
I need more answer, more answer. Let it be wrong. Let me, from the wrong answer, somebody will be telling the right answer also.
Ma'am, because t equal to zero, right? That time.
You, why you are going for the complicated thing? Simple, go to your KVL equation. Simply go to your KVL equation. Your KVL equation is valid. When you have closed the switch, KVL equation is valid. So what will be the value of VL?
V.
मैम V minus
Who
VR.
answered? Who answered? Who answered? Girl student. Who answered?
841, 841.
Would you tell me your name?
Sushri Samit.
Susri. Very good. Very good. I am very happy with your answer. He told simple KVL equation. You just put the KVL equation. What is my KVL equation? I have closed the switch. What is my equation? What is my equation? V is equal to how much? V is equal to VL
VR.
plus how much? VR.
VR.
Simple.
VR.
My VR is equal to 0 because my I is equal to 0. So what happens to the VL? VL is simple V. What happens to T at infinite? T at infinite. What happens to your VL? Tell me. What happens to your VL?
And V plus VR.
VL is equal to?
V minus VR, sir.
VL is equal to? VL is equal to how much?
From 0.
तुम लोग को ना सब मार पड़ेगा जितना बॉय स्टूडेंट है वो मार पड़ेगा नन ऑफ यू आर आंसरिंग यहाँ पर तो लिखे हो हाँ? क्या 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 बोल रहे हैं क्या क्या अरे डी बाई डी टी मेरा कितना है
मैम जीरो होगा ना.
Ma'am,
जीरो तो होगा जीरो तो बोलो कहाँ क्या क्या इक्वेशन बोल रहे हो तो वी एल इज इक्वल टू 0 okay at that time V is equal to how much same V KVL equation is valid VR plus BL is equal to V. What is my VR? VR is my maximum that is equal to I into R. So what is my VR? VR is equal to how much? Tell me. VR is equal to how much? V that is equal to I
VR equal to V.
into R. समझ में आ रहा है क्या हो रहा है एक्चुअली कंडीशन समझ में आ रहा है नहीं सिंपल इतना कॉम्प्लिकेटेड नहीं है इनिशियली VL is equal to V what happens to your VR VR is equal to 0 understood यहाँ पर क्या रहा है उल्टा हो रहा है VL is equal to 0 VR is equal to how much I maximum into R understood all of you यहाँ पर किसी को समझ में नहीं आया है those who have not able to understand tell me I will repeat don't worry you are
Can you repeat it again, ma'am? The last.
हाँ मैं रिपीट करती हूँ सुनो ध्यान से सुनो देखो just you see simple I have connected a resistor and one inductor okay I will connect it with the help of switch the voltage source. Okay. So now what happens? I will close the switch at t equal to 0. I have closed the switch. My switch is not open, right? So this is my VR, where my equation is equal to VR is equal to I into R. What is my VL? VL is equal to L di by dt. All of you understood? जहां पर समझ में नहीं आ गया मुझे बोलना. इधर समझ में नहीं आ गया मैडम repeat. VR plus VL. This equation is valid. I have closed the switch. Okay. Understood all of you? Now, at t equal to 0, t equal to 0, because due to the presence of the inductor, it will not allow current to flow, because I just at t equal to 0, I am closing the switch. So before closing of the switch, my current was 0. So immediately just after closing of the switch, I am discussing about the instant I have just closed the switch. My current will be equal to 0. Why? Because due to the presence of what? Because due to the presence of what? Tell me. Presence of inductance. Okay. So what is my I equal to 0 means simple. My VR is equal to 0. So what is my VL is equal to how much? Capital V. VR is equal to 0. Understood now? What happens just at the instant I have closed the switch? Got it? Now coming to the third instant. T at infinite. A long time I have connected the switch to the circuit. What happens to my equation? Tell me. What will be my equation? Now, I have connected, listen one thing. I have connected the switch. Okay, my current will definitely rise because I have connected the supply voltage to the circuit. My current will definitely rise. So from I equal to 0, I will increase. Yes or no? Tell me.
Yes, ma'am.
I will increase. Simple concept. I will increase. So I is increasing means what happens to my VR? VR is equal to I into R. This will increase, right? This will increase. Got it or not? So what happens to my, as V is constant, what happens to my VL? VL will decrease. Understood or not? What happens to L di by dt? This will decrease. So what happens to di by dt? This will decrease. Understood or not? Got it or not, all of you?
Yes, ma'am.
Yes, ma'am.
यहाँ पर समझ में नहीं आया? आया तो?
Yes, ma'am.
Yes,
Okay,
ma'am.
great. So di by dt will decrease. Now decrease करते, now here it is decreasing. Now it will decrease and decrease and decrease and decrease, and the process will go on and becomes 0. Okay. So when it will be 0, when di by dt will be 0, at that time, when I have closed the switch for a long period of time, this will be at which case? At which case it will be 0? T at infinite. So T at infinite, what will be my di by dt? Tell me. Long time I have closed this. So that's what I have put it in a dotted line. So di by dt will be equal to 0. So simple, what will be my VL? VL will be equal to 0. So what happens to my VR? Simple, Kirchhoff's voltage law. VR will be equal to T. It will be equal to I into R, where it is equal to I maximum into R. Now you understood what happens in between t at 0 to t at infinite. All of you got it now? Those who have asked me to repeat.
Yes, ma'am.
Yes, ma'am. Got it.
Clear?
Yes,
Okay. Simple thing has happened. Any confusion? Any difficult है? कुछ difficult है? तुम लोगों का क्या हो रहा है अंदर?
No, ma'am.
Okay. So now very interesting. तुम लोग जब practical करोगे ना देखोगे ये सब वो चीज हो रहा है. Okay. So now come to what I will discuss now. At any instant. At any instant. In instant means t greater than 0, less than infinite. This is your condition number 2. That is your DC transient. What happens? What happens now? V is equal to IR plus L di by dt. This is my equation. Yes or no? Tell me. Is it okay? Neither of them is 0. Neither VR is equal to 0 nor VL is equal to 0. So I can write down V minus IR is equal to how much? L di by dt. Clear? Am I clear?
Yes, ma'am.
Okay, so now all of you write with me. Wherever you will not able to write, tell me. I will stop there. Huh? So now V minus IR is equal to L di by dt. So this implies di by V minus IR is equal to, you will check it, di divided by L. Okay, clear? Now multiplying both sides.
Ma'am, that's
Mul
मैम
क्या
dt
बोले?
होगा.
मैम dt होगा ना.
हाँ, dt, good. Thank you. So this is dt divided by L. So multiplying both sides by minus R. I will multiply both sides by minus R. Then what I will get? Minus R divided by V minus IR into di is equal to minus R divided by L into dt. Okay. So this implies, now what I will do, I will integrate both the sides. Integrating both the sides. I will integrating both the sides. Integrating
ma'am, please move the
both
slide up.
both the sides. लिखो.
Okay, ma'am.
845 is there in your section, Tarish, or offline?
Ma'am, he is in this section.
Tarish not responding. Dipanjan, not responding. क्लास में absent करो. तरीश, दीपंजन, लिख लिए. अर्नव,
Yes, ma'am, written.
867. Okay. So now Arnav respond. Arnav, or who respond? Arnav is there? So now integrating both the sides, what you are getting? Ln B minus IR is equal to minus R by L T plus K. Okay. So now you can get the integration constant. Okay, K is, you can take at t equal to 0. At t equal to 0, what is the value of current? Current is equal to 0. Okay, so at that time K is equal to ln V. Now substituting here, what you will get? Ln V minus IR is equal to minus R by L T plus ln V. Okay, understood? So here ln V, so here I can write down ln V minus IR divided by V is equal to minus R by L into T, or this implies V minus IR is equal to V e to the power minus R by L into T. Okay, or this implies I is equal to how much? V divided by R, 1 minus e to the power minus R by L into T. Okay, so here you see from the current equation, what T at 0, what is the current? Is it 0? Yes or no? Yes or no? T at infinite, what is the current? I is equal to V by R. This is your maximum current. Are you getting it or not?
Ma'am,
मैं
it's
वहाँ RT by L होगा.
Yes.
हाँ हाँ, क्या 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 बोल रहे हो?
RT by L होना चाहिए.
माइनस RT बाय L होना चाहिए क्या?
हाँ, मैं तो वही
After
लिखी
power.
हूँ. हाँ हाँ, वही तो लिखी हूँ. नहीं नहीं नहीं, वो टी है, वो मल्टीप्लाई विथ टी है. आर बाई एल टी नीचे नहीं है, वो ऊपर ही है. यहाँ पर वो ऊपर ही है, आर टी बाई एल. ओके. Subham, are you writing? 829. Understood? Subham Pal. Subham Pal. 829 is not there. Sasi Prakash. 828.
Yes, ma'am.
824. Satyam.
Excuse me, ma'am. Ma'am, थोड़ा ऊपर. Ma'am, can you please move up? Hello.
Satyam.
Hello.
हाँ हाँ.
Ma'am, okay, okay.
Satyam, are you there? Sharvajit.
Yes, ma'am.
Satvik. Satvik Naresh. Rishabh Prasad.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Rishabh
Yes, ma'am.
Chakrabarti. Rishabh Chakrabarti.
Yes, ma'am. I'm right.
Rishabh Chakrabarti, you understood everything?
Yes, ma'am.
Priyesh.
Yes, ma'am.
Priyesh.
Yes, ma'am.
Priyam Ghoshal.
Yes, ma'am.
Okay. So here, this is your equation. Now come to the. Now suppose I will ask you, what is the initial rate of rise of current? What is the initial rate of rise of current? What is the initial rate of rise of current? By mistake, I have installed the new version of Microsoft Whiteboard, and it is creating a lot of problem. So yes, I was asking, what is the initial rate of rise of current? Tell me. What is my equation? Tell me. V is equal to how much? IR plus L di by dt. मतलब वो पेन दबा कि मैं अटेंडेंस करे और ये मार्क करी आपसे, है ना? तो पेन बोल दबा, पेन वो चैम्बर थी, वो चैम्बर न बबीता मैडम थी तांको. So this is your. Now what is my current? Current is equal to, initially it is equal to how much? 0, right? Yes or no? So what is my di by dt? If I will ask you what is my di by dt, dy by dt
V
is equal
minus
to
IR by L.
why IR? Why IR? कहाँ गया?
IR is equal to 0.
Okay, IR is equal to 0, right?
Yes, ma'am.
So this is equal to initial rate of rise of current is equal to how much? V divided by L.
Yes.
This formula you remember. It is unit will be ampere or second. Okay. So this is your equation. Now come to the time constant. Yes. Here I will draw the graph between, if I will draw the graph between the voltage across the current and voltage across the current, voltage across the resistor. नहीं लैपटॉप पेन हुए, लैपटॉप पेन. अरे पेन ठीक है, अटेंडेंस वाला मार्क करिए आपसे. VR and I will with current, with time. Then I will draw VL with time. Then I will draw current versus time. How will be the graph? Just analyze. Initially, what is the voltage across the resistor? 0. Okay. What is the voltage across the? Listen first, then we'll draw. I will give you time. Don't worry. Listen first your concept will. अगर तुम लोग ना class में I am what I am observing. Many of you are not responding. क्या होगा बाद में तुम लोग ही पढ़ोगे, खुद पढ़ोगे। क्लास में क्या अटेंटिव क्यों ले रहे थे? यहाँ पर तो तुम कोचिंग नहीं ले रहे हो ना, जैसे 12th में ले रहे थे। क्लास में अटेंटिव रहो, उसके बाद चले जाओ। 10 एब्सेंट सब डिवाइड कर दूंगी इस बार। नॉट एबल टू गिव एग्जाम। So here, what you will do? VR is equal to how much? Initially t equal to 0. What is the value of VR? See, VR is equal to how much?
0.
V or 0?
Ma'am, 0 ना. We are equal to initial.
VL कितना होगा? VL
equal to V. We are equal to.
अंडरस्टूड और नॉट?
Yes,
T at
yes,
0 में हम लोग करेंगे। पहले देखो, अच्छी तरह से देखो पहले। So initially my VR is equal to 0. Then VL is equal to how much?
Ma'am, V.
Yes or no? What is my current? Current is equal to how much? Current is equal to how much? 0.
Ma'am, 0.
Okay.
Current was 0.
Now, yes. T at infinite का condition है? T at infinite में क्या है? Current is maximum.
Yes, ma'am.
Current becomes maximum. Voltage across the resistor is also maximum.
Maximum.
What is the voltage across the inductor? Inductor will be 0. समझ
0.
में आ रहा है नहीं?
Yes, ma'am.
Got it or not? All of you understood the graph?
Yes, ma'am.
Clear to all of you? All of you understood? All of you. Don't feel shy for asking.
Yes, ma'am.
Yes, ma'am.
Okay. So in between, you tell me the equation only. What is the equation? Voltage across the resistor. What is the equation? Tell me. Tell.
The voltage across the resistor.
इतने टाइम ले रहे हो? वोल्टेज रजिस्टर क्या इतना बड़ा क्वेश्चन?
V minus L di.
यहाँ पर तो मिल जाएगा ना?
Yes, ma'am.
यहाँ पर हाँ, so V is equal to IR. How much it is? VR is equal to IR. That is equal to how much? Capital V into how much? E to the power minus RT by
L.
कितना? छवि, you understood both of you?
Yes, ma'am.
One minus e to the power minus R by L into.
Ma'am, can you show that equation?
सही है तो?
Yes.
हाँ, I will show the equation. See. Got it?
Yes, ma'am. Got it.
Okay. So what is your current equation? What is your current equation? Tell me. Current का कितना था equation? I maximum into how much? 1 minus e to the power minus R by L into T. ये तो है? Yes or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. And what about this one? What happens to VL? VL is equal. हाँ, VL का क्या है इक्वेशन? अरे VL का क्या होगा इक्वेशन? What is the voltage across the inductor equation? Equation, I want equation.
V minus VR.
अरे ये एक्सपोनेंशियल इक्वेशन निकालो.
And V minus V है.
What V minus VR? तुम करके मुझे बोलो.
V e to the power minus RT by L.
E to the power minus R by L into T.
T.
Okay. समझ में आ रहा है नहीं?
Got it.
ओ ये R by L into T. Okay, मेरा तुम लोग कंफ्यूज हो जाएगा. ठीक है, हो गया?
Yes, ma'am.
Understood all of you? Okay. So now come to time constant. Here we will define time constant. How you define time constant? How will you define time constant? I is equal to how much? I maximum 1 minus e to the power minus r by l into t. Okay, so you put lambda t is equal to lambda, that is equal to l divided by r. Okay, this one you put. So what you will get, tell me? What you will get? I is equal to how much? I is equal to, I will be equal to how much? Tell me. It will be I, capital I, it will be capital
0.37
1 minus e to the power, e to the
RT
power
minus
minus
RT by
1.
L.
That will be equal to
0.63.
0.37.
0.632 into I. Okay. So now here I will show you which one is the time constant. Here I will show you time constant. It is here, it will be equal to how much it is? 0.632 into I. Okay. So how will you define time constant, tell me? How will you define time constant? It is the time taken, write down. It is the time taken, it is the, it is the time taken by the inductor current to reach to how much times? Time taken by the inductor current
To reach 0.632
To increase its value.
to reach to how much?
0.62.
0.6.
0.632 times of what? Maximum value. Times of maximum value. Understood all of you?
Yes, ma'am.
Written all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Now come to decaying. Decaying बहुत easy है. Decaying में क्या होगा मुझे बोलो? Decaying of current. ये rising of current, यहाँ होगा decaying of current. Okay. So now here I will draw the circuit decaying of current. Where you will not able to understand my handwriting, tell me. This is your R. This one is L. Now this is position 1. This is position this is
मैम
position
सर्किट
number
पूरा आड़ा
1.
टेढ़ा बन गया, समझ नहीं आ रहा मैम.
अरे मेरा तो वही प्रॉब्लम हो रहा है. मैं उसको आज जैसे भी वो ओल्डर पर्सन, अरे मैं जो बना रही हूँ ना वो 5 मिनट के बाद ड्रॉ कर हो रहा है. मेरा बोर्ड मैं जो ड्रॉ कर रही हूँ ना वो 5 मिनट के बाद वो जैसे ड्रॉ हो रहा है.
लैग हो
प्रॉब्लम हो
रहा
रहा है. मुझे भी प्रॉब्लम हो रहा है ना. हाँ लैग हो रहा है.
फोल्डर वर्जन
जैसे भी हो आज.
है. मैम नया फोल्डर बना दीजिए. फोल्डर लैग हो रहा होगा सर. नया फोल्डर बना दीजिए. नया पेज.
अरे कभी भी ऐसे नहीं हो रहा था एक्चुअली. कोई
फोल्डर वर्जन में कर लीजिए मैम.
हाँ ओल्डर वर्जन तो मैं इंस्टॉल नहीं कर पा रही हूँ, मैं आज बोली हूँ एसटी सेल को कर देंगे, ओल्डर वर्जन ही हो रहा था। अच्छा ये बाय मिस्टेक एक्चुअली आई क्लिक्ड ऑन टू द न्यू इंस्टॉल द न्यू वर्जन, बाय मिस्टेक आई क्लिक्ड इट।
मैम आईसीटी सेल के पास मैम कोई भी कंप्लेन लेके जब वो पूरा बोलते हैं फॉर्मेट करो कंप्यूटर को।
हाँ नहीं, तुम कहाँ आए हो बोल रहे हो?
मैं जितनी बार गया हूँ उतनी बार मेरा फॉर्मेट हुआ है।
ये कितने बार आए हो तुम?
6 से 7।
तो नया कंप्यूटर?
यस मैम इसी साल अभी जो मिला था मैम, 1 महीने के अंदर में 7 बार गया जब मेरे को लैपटॉप।
कौन सुप्रा सर?
मैम सत्य
नहीं ना।
यस मैम।
अरे we have worked here around 11 years in my for me, and so many times we have gone. They have solved wherever it is required for formatting. They will tell. Otherwise, okay. So here, what? Suppose you consider an instant. The solution was initially at position number 1. Now it will be switched to position number 2. It will be switched.
मैम साइड में 3 है मैम, वो अलग अलग मैम ओपन स्विच है।
हाँ ये मेरा स्विच है, this is switch. It is position number 1. This one is position number 2. Okay. So think of a condition. Listen. Think of a condition. The position was the switch was connected to position 1. Now it is connected to position number 2. Okay. Think of a condition when the switch is thrown to position number, write down, when the switch is thrown to position चित्र लिखना है हाँ टिक्के मो क्लास रची टिक्के बस टिक्के मोर सर्जुवे क्लास जस्ट 5 when the switch is thrown to position number, initially you think of a condition the switch is at position number 2. What will be the condition in the circuit? Tell me.
चार्ज होना शुरू होगा, करंट 0 होगा उस टाइम,
करंट इंटू 0 होगा उसी टाइम. नाउ इट विल go it will go to maximum. Yes or no?
Yes ma'am.
अच्छा, one thing I will tell you now. Listen all of you very carefully. During the rising of the current, what happens to the a long time the switch has been closed. I have closed the switch a long time. What happens to this inductor? Inductor voltage will be equal to how much? Look at your circuit. Look at the previous one and tell me.
0.
What will voltage is 0. Now there is no potential difference. No potential difference means what? No potential difference means what? There will be, it will behave as what? It will behave as short. Got it or not? So here, one thing you will mention here in the previous one, that inductor behave as what? Inductor behave as short circuit. Behave as short circuit. ओके तुम इंडक्टर को एक ये चीज तुम कर सकते हो लैब में. जस्ट यू गिव सम वोल्टेज टू एन इंडक्टर, व्हाट विल हैपन यू नो, there will be, it will act as a short circuit. That means it will act as a pure conductor. It will not work. इंडक्टर का जो फंक्शन है वो कुछ फंक्शन ही नहीं करेगा, वो it will behave as a simple conductor. Understood or not? Got it or not? Or again I will tell you.
No ma'am, got it.
Got it? So a long time you will close. That long time is very less time. That long time you are telling that t at infinite, t from t to 0 to t to infinite, that period is very less. That is a very fraction of a second. That is why you are calling it as a you are calling it as a transient. Transient means sudden change. It's not that you have to wait for some time. Immediately it will behave as a short circuit. Understood? That is the reason why we are not able to use these inductors and capacitors while using a DC circuit. While analyzing DC circuit, you have never used inductors and capacitors. Am I clear or not?
Yes,
Got it or
yes,
not?
ma'am.
Okay. So now I will just discuss the part position number 1 and 2. Next class we will continue. Okay. Now when the position, when the switch is thrown to position number 2, what is the condition of the circuit? Tell me. Current
Then
is
zero
equal to
current.
maximum. Why zero current?
Then current will be flow ना. Then जब 2 पे connect होगा तो
Why
शुरुआत में तो
current
zero
will be
होगा ना.
zero?
It will be I max.
I will be I maximum. Okay, just now I have discussed na. So what
T0
happens
पे
to
तो zero होगा ना.
T0 पे जीरो क्यों होगा? देखो कट सर्किट का कंडीशन देखो.
Circuit flow है.
सर्किट देखो. When I is a maximum, long time. Listen.
T infinite.
Long time the switch has been closed to position number 2. A long
Yes, yes,
time.
होगा.
Okay, a long time the switch has been closed to position number 2. Then what happens to my current? Current is equal to maximum, VL is equal to 0 and VR is equal to how much? V. Now you think of a condition when you have now removed the switch from position number 2 and you will close it to position number 1. Okay, you will close it to position number 1. This we will be discussing. In here, decaying of the current. Why decaying of the current? Because you have not connected any voltage source. Okay, so what will happen in here in this case? Tell me, what will happen? Tell.
Current flow होगा. Current कम होगा धीरे-धीरे और flow होगा.
करंट कम होगा धीरे धीरे फिर फ्लो होकर के
लॉन्ग टाइम जीरो हो जाएगा.
हाँ उसमें एक थोड़ा टाइम बाद zero हो जाएगा.
लॉन्ग टाइम इट विल बिकम व्हाट?
Zero.
It will become, the current will become 0. Initially what is the current? Tell me. When I will just answer me one question. Think and answer. The instant I am closing the switch to position 1, what is the current in the circuit?
I max.
Very good. That's why I wanted. I maximum. Why? Because a long time the switch has been closed to position number 2, the current was maximum. So when you will remove the switch from position 2 and you will connect it to position 1, due to the presence of the inductor, the same current will flow. Am I clear or not?
Yes,
So
ma'am.
it will be, the current will become maximum the instant I am closing the switch to position number 1, and a long time I have connected the switch to position number 1, the current will be equal to 0. That I will discuss. How is it happening? Understood all of you?
Yes, ma'am.
Clear
Yes,
all
ma'am.
of you? Okay,
Yes,
very
ma'am.
good.
Yes, ma'am.
Okay, ma'am.
Okay, चलो तुम लोग जाओ.
Attendance?
अटेंडेंस में हो गया जिसका